Good day, everyone. In this exercise, we have a piston cylinder arrangement containing a refrigerant R134A in a saturated vapor state and at minus 10 degrees Celsius. It's compressed to a pressure of 500 kilopascal in a polytropic process. So we have state number 1. Temperature is minus 10. And the other independent intensive property given is the saturated vapor. This has gone under a polytropic of n equal to 1.5 to state number 2, where we have pressure 500 kilopascal, and we need to find the temperature and the volume. This is the piston, and this is the cylinder. Our controlled mass can be taken as such. This is our system. It's a closed. This means that mass is the same as the masses in all states. Therefore, we can write the polytropic process as pressure specific volume and the specific volume at state 2 can be expressed in terms of the ratio of pressures as well as the specific volume in state 1. Finding the specific volume 2 will allow us to calculate the volume in state 2, since the mass is already given as 0.5 kilogram. In order to find the specific volume in state 2, we need to find the specific volume in state 1 and the pressure in state 1 as well. These can be found since we already have two independent intensive properties. Once we find the specific volume in state 2, we can find the temperature in state 2. Since now we have a pressure and the calculated specific volume, we will be able to find any property involved. As for determining the work done, this can be done in a straightforward way using the relation of work as a function of pressures and volumes and the value n, which we will calculate in a minute. Now let's calculate the specific volume and the pressure for state 1 using table B51. You will find that at a negative 10 degrees Celsius that the saturated pressure is 201.7 kilopascal, and the specific volume for a saturated vapor state is 0.09921. So at negative 10 degrees Celsius, the P of state 1 is the saturated pressure, and the specific volume corresponds to the saturated vapor specific volume, which is 0.09921 meter cube per kilogram. Now we have all the specific volume and pressure state 1, and we have the pressure for state 2, which is 500 kilopascal. We can calculate the specific volume in state 2. This is equals to 0.0542. Now from this value we can calculate temperature in state 2. In order to calculate the temperature, we need to find where we are in state number 2. So we go to table B52 and we need to check at 500 kilopascal the specific volume just calculated and compare it with the specific volume of the liquid and that of the saturated vapor. What you will notice that in table B51 for 134A refrigerant, there is no pressure entry. However, you can work out the specific volume at the saturated vapor line by interpolating between the two pressures at 489.5 and 572.8. However, we don't need to do this because if you look at the worst case, which is the 489.5, where the dome is flatter or wider at the bottom, you will find that the saturated vapor value is 0.04213. This is the specific volume at the saturated vapor line. And if you compare this value with our calculated value of 0.05, this is bigger than the saturated vapor at 500 kilopascal. Implies we are in the superheated region. So in order to calculate our temperature again, we have to go to the superheated table and find values above and lower than the specific volume V2. So this is more the case. This is 500 kilopascal, and you will find that our value is between the temperature of 70 degrees and that of 80 degrees. Our specific volume is between these two values, 0.052 and 0.543. Doing the interpolation, assuming the relation is linear, and as shown in previous exercises, this can be found as Now when it comes to calculating the work, we can use the following formula. This is equals to a negative 7.07 or around 09 kilojoule. Obviously, we are adding work to compress the piston, and this indicates a negative sign. Suppose that this is the pressure versus specific volume. Let's assume that this is the dome for the refrigerant. We start at some point in the saturated vapor here. So this was assuming this is the starting point. We have compressed the piston. This means that the volume is decreasing and the pressure is increasing. So we're going up, but we're going up to the left in a polytropic process somehow like so. And this is the final state, which was superheated. And the initial state was saturated vapor. So for us to have gone from this state, saturated vapor state, to superheated, work was added. And the work amount added was a negative 7.09 kilojoule. As a result of this, we have reduced the volume and increased the pressure. The pressure value 500 kilopascal, and the initial value we found was 201.7 kilopascal. We can also have a amount of heat transfer to the outside environment. So this is state number 1, and this was state number 2.